Okay, let's have the next lesson, the Cauchy linear equations. Now, any linear differential equation of the form, okay, look at this differential equation. This is a sub n x to the n, okay, nth derivative of y with respect to x, plus a n minus 1 x to the n minus 1, n minus 1 derivative of y with respect to n, plus and so on, a1x, okay, dy dx plus aoy is equal to f of x, okay, where the coefficients an minus 1, ao are constants, is called a Cauchy-Euler equation. Now let us analyze, okay, this equation. Now look at this a sub m, an minus 1, and a1 and ao. These are all constants, okay, these are all constants. And look at the power of n. The power of n is the same as the order of the derivative of y. In the same manner here, this is n minus 1, this is the same as n minus 1, this is 1, and this is 1. So generally speaking, the power of n, the power of x, is the same as the order of the derivative, okay, of the unknown derivative of y. Now, these are the transformations that we're going to do. Our c is len of x, okay, and our dc dx is the same as 1 over x, is the same as e to the negative c. And we define our d, the operator d is the derivative of d with respect to c. So these are the formulas that we will have to, okay, apply, and this can be derived. Xy prime is the same as dy, x squared y double prime is the same as d minus 1 times dy. It's easy to remember this. And x cubed y triple prime is the same as d minus 2 times d minus 1 times dy. Of course, this can be extended as, let's say, x to the fourth, y to the fourth will be equal now to d minus 3, d minus 2, d minus 1, dy, and so on. Okay. Okay, let's have the first example. Let's call this example 1. Now we have x squared y double prime minus 2xy prime plus 2y is 0. The question is it what? Is it a Euler-Cauchy? Now, look, okay, the power of here, this is 2, this is the same as second, okay, this is 1, this is the same as first, and 2y is 0. Okay, as well as the coefficients of x are all constants. So basically, this is a Euler equation, Euler-Cauchy. So we will now apply this one. X squared y double prime is what? Is d times d minus 1y, where we remember that d equals ddc, and x y prime is dy. So we are going to plug there. So plugging it there here, you have d times d minus 1y, okay, minus 2 dy here, okay, and then plus 2y is 0. And then simplifying, of course, that's the same as what? That's the same as, this is the same as d squared minus dy. So this is here d squared minus d, and then what? And then combine this minus 2 and 2d and 2 there. Then simplifying, this gives you what? This gives you, okay, this is negative d minus 2d, that gives you negative 3d, and then plus 2y. So there is a parenthesis here. Then factoring the roots of the auxiliary equation, you have what? M squared minus 3m plus 2 is 0. This can be factored into m minus 1 times m minus 2 is 0. So our y sub c is c1 e to the c plus c2 e to the 2c. Now remember that our transformation is x equals what? X equals e to the z, or c is len of x. Then you can what? Okay, here where c is len of x. So you can simply substitute here in this c and c there. You have y is c1 e to the len of x plus c2 e to the 2 len of x. Now e to the len of x, alright, e to the len of x is just equal to x, and e to the 2 len of x is just equal to x squared. Therefore, our general solution is, okay, y equals c1 plus c2 x squared. Okay, here is another example. Okay, we have x cubed y triple prime plus 6x squared y double prime plus 8xy prime minus 8y is x squared. Now, is this a Euler? Okay, is this a Euler equation? Now, notice that you have x cubed and y triple prime here. Exponent and order the same. X squared and y double prime, exponent and order the same. X and y prime, exponent and order the same, minus 8y equals x squared. Okay, and then also the coefficient of x cubed y triple prime, x squared y double prime, x y prime, and y are all constants. They are 1, 6, 8, and negative 8. So therefore, this is a Euler equation. So our transformation will become what? X cubed y triple prime is d minus 2 times d minus 1 dy. Our x squared y double prime is d minus 1 times dy. And our xy prime is dy, where our dy is of course equal to dy dc, okay, and x is equal to e to z. So okay, now we plug. Okay, we plug here that x cubed y double prime y triple prime, this x cubed y triple prime there, okay, was plugged this one d minus 2 d minus 1 dy, and then x squared y double prime plug what? D minus 1 6 what? D minus 1 dy, and then that 8x is plugged, which is simply what? 8 what? 8xy prime is plug 8 dy, okay, equals, remember that our x is e to the c, therefore your x squared is what? Your x squared is e to the 2c, then e to the 2c. Now simplifying, okay, you have what? Okay, you have, okay, let's just remove this. Okay, look at this. Alright, d times d, that's d cubed, and then this is negative 2d and negative d, that is negative 3d, and then times d is d squared, and then negative 2 times negative 1 is plus 2d. And this is 6d times d is 6d squared, 6 times negative 1 times d is negative 6d, and then plus 8d minus 8, and then y equals e to the dc. Now simplifying, this is simply what? This is simply d cubed. Now you have combined negative 3d squared and then plus 6d squared, that is 3d squared, and then 2d minus 6d plus 8d, that is 10 minus 6d is 4d, minus 8y equals e to the 2c. Now the auxiliary equation now is m cubed plus 3m squared plus 4m minus 8 is 0. Now you can factor this as m minus 1. Now you can use what? You can use synthetic division here. From here, this is 1, 3, 4, and negative 8. Alright, let's try 1. Now this is what? This is 1, 1, 4, 4, 8, 8. 8 times 1 is 0. So what remains is the m squared plus 4m plus 8 is 0. This is the m squared plus 4m plus 8 is 0. And using, okay, m is 1, and here is simply m is negative 2 plus 2i. So the roots for m squared plus 4m plus 8 is negative 2 plus minus 2i. You can use a quadratic formula, or you can simply complete the square. And then our complementary solution is z1 e to the c based on this one plus e to the negative 2c, c2 cosine 2c plus c3 sine 2c. Remember that our dy is the same as dy dz. Now to get the particular solution for x squared, okay, uh, your e to the c is e to the 2c. Now this is e to the 2c. So our particular solution based on the method of undetermined coefficients is yp is a to the 2c. And then plug it in this equation here. This equation, this is the same there, plug it there. Yp should satisfy this one, d cubed plus this 3d squared plus 4d minus 8y equals e to the 2c. Okay, so get yp prime from here, that is 2a e to the 2c, yp double prime, that is 4a e to the 2c, and yp triple prime is a e to the 2c. And then plug it there. So d cube yp, this is d cube yp, that is 8 e to the 2c. The d squared yp is 3 times 4 a e to the 2c. Okay, the 4d, this one, 4 times 2 a e to the 2c minus 8, your yp is what? A e to the 2c. I can combine this. This is 8 plus 12 plus 8 minus 8. That just gives you what? 20. A e to the 2c equals e to the 2c. You can solve for a here. Of course, your a is 1 over 20. And then plugging it there in the yp is a to the 2c. You get what? Yp is 1 over 20 e to the 2c. And remember that y is the sum of the complementary and particular solution. So our complementary is this one, c1 e to the c, this one, plus c2 e to the negative t cos 2c cosine 2c, plus c3 e to the negative 2c sine 2c, plus 1 over 20 e to the 2c. But remember this transformation, x is e to the z. So if x is e to the c, then what? Then c is ln of x. Now remember, z is what? Z equals ln of x. So you can substitute there. Okay, this becomes, remember, this becomes c1 e to the ln of x. Okay, e to the ln of x, and then plus what? Plus c2 e to the negative what? 2c 2 ln of x cosine 2c cosine of what? 2 ln of x, plus and so on. Notice that e to the ln of x, that is c1x, that e to the negative 2 ln of x, that's the same as x to the negative 2, and then this is 2 ln of x, and then that is c3 e to the negative 2c. Now this c3 e to the negative 2c, that is, remember, e to the what? Negative 2 ln of x, okay, that is equal to x to the negative 2. That's why this is x to the negative 2 sine 2 ln of x, okay, plus 1 over 20 x squared. This is now our general solution.